Have you ever wondered why derivative of sine is cosine, or how tangent derivative turns into secant squared? Stick around, because today we are diving into the fascinating world of derivatives of trig functions. Whether you are prepping for calculus or just love math magic, I promise this is where it all clicks. Now, we have these are some things that you have to know. The derivative of sine x will always give you cosine of x. So if you differentiate cosine of x, you get negative sine of x. If you differentiate tan of x, you get secant squared, and also these properties. Now we also have to know these basic properties. So whenever you differentiate tan x is equivalent to, say, sine of x over cos of x. Cotangent is the inverse, so we have cos of x over sine of x. Secant is always 1 over cosine, and cosecant is always 1 over sine. Now, there is no need for you to memorize these basic things, right? For instance, so you can use these 4 properties to derive the above. So we can use these 4 properties, right, to derive these properties above here. So now, for instance, let's consider this. d dx of tan x is equal to secant squared of x. But how did we get secant squared? Note that d dx tan x is the same as sine of x over cosine of x. Now remember, we can use the quotient rule to differentiate this. From the last video, I made mention of the fact that whenever you have two functions that are continuous, so this is your f and this is your g, and you are dividing, you always use quotient to differentiate. So quotient is, let's say you have two functions f and g, and you want to differentiate. This is g of f prime minus f of g prime out of g squared. So in this case, our f, always remember your f is a numerator, so our f is sine x and our g is cosine of x. So if we differentiate f prime, remember sine of x, if you differentiate you get cosine. If you differentiate cosine, you get negative sine of s. So making the substitution, we have our g in this case is what we had over here. So we have cosine of x. Our f prime is also cosine of x. And then minus our f, which is sine x, multiplying g prime, which is negative sine x. So negative and negative makes this positive. So you can just multiply this by sine s instead of negative sine s. And g squared is cosine of x or squared. So we can simplify this to cos squared of x plus sine squared of x. Then this is going to be cosine of x. Or we can also simplify that one as well. So we can have cos squared x over there. One thing that you have to note, that cos squared of x plus sine squared of x is equal to 1. So right from this place, let me copy this one right here. So right from here, we can say that this is equal to 1 over cos squared x, which can be written as 1 over cosine of x multiplying 1 over cosine of x. But we know that 1 over cosine is secant. Over here, we know that 1 over cosine gives secant. So in this case, we have secant of x multiplying secant of x, and this is equal to secant squared x. So if you don't know the derivatives of these offhead, you can just prove it, right, using the basic identities that we have over here, just that it takes time. So if you don't want to memorize, this is a way of trying to prove it. Now, let's move on. Let's use these properties to then solve some questions. So let's consider this first example. We have to find the derivatives of the following. The first one is y equal to x squared minus sine x. Now note, to find the derivative, we have dy dx. This is equal to d dx of x squared minus d dx of sine x. So dy dx is equal to, now remember, if we differentiate any polynomial term, the exponent always comes down, then you subtract 1 from the exponent. So now if you subtract 1 from 2, we have 1, so you can choose not to write it. Then minus. Now if we differentiate sine of x, you get cosine of x. So this is going to be your answer. We can also have this. Now let's look at b. b is, if we have y equal to e to the x sine of x. Now with this question, since we have two functions and we are multiplying, we have to use a product rule. And remember, the product rule is, if we have two functions, we have f of g prime then plus g of f prime. So always your f should be your first function, your g should be your second function. If we differentiate this, so if you differentiate f, remember, whenever you differentiate e to the x, you get the same thing. And when you differentiate sine of x, you always get cosine of x. So now we can do our substitution. So we have f over here. So in this case, our f was ex, our g prime is cosine of x, plus our g, which is just sine of x, and our f prime is e to the x. So we can have dy dx, so we can choose to bring e to the x outside. Then we have cosine of x plus sine of x. I hope this is clear enough. Now let's look at a third question. For this, let's have y equal to 5x plus cosine of x. So over here, we can have dy dx is equal to d dx of 5x plus d dx of cosine of x. So we have dy dx. Remember, whenever you are differentiating this and you have a constant, remember the constant multiple rule, you always bring the constant outside. So you have d dx, then e to the x plus d dx, then cosine of x. So we have dy dx is equal to 5. And as we know, if we differentiate e to the x, we get the same thing. Then plus, if we differentiate cosine of x, remember you have minus sine of x. When plus and minus always meet, we have negative, so this simplifies to 5ex minus sine x. I hope this is clear. Let's look at the fourth question. For the fourth one, let's look at a little bit complicated question. That is, if you have y equal to cosine of x out of 1 minus sine x. Now tell me, without even solving, right, which approach are we going to use? Are we going to use the quotient rule? Are we going to use the product rule? Are we going to use the power rule? Like, what comes in mind? Note, whenever you have a fraction, right, you always use the quotient rule. So in this case, we just want to differentiate cosine of x over 1 minus sine of x. And remember the quotient rule, so we have dy dx, this is equal to g of f prime minus f of g prime out of g squared. Your f is always your numerator, your g is always your denominator, your f prime, if you differentiate cosine of x, you have negative sine of x. If you differentiate this, if you differentiate 1, it goes to 0, so you have negative. Then if you differentiate sine of x, you get cosine of x. So doing your substitution, you have g, which is just 1 minus sine of x. You have f prime, which is minus sine of x. Then minus your f, which is cosine of x, times g prime, which is minus cosine of x, out of g squared. So g is 1 minus sine of x all squared. So now we have our dy dx to be equal to, now if we distribute this right here, we have negative sine of x, then plus sine squared x. And if we distribute this, we have positive, because negative and negative right here. So we have positive cos squared of x dividing 1 minus sine of x all squared. So the y dx is, remember, sine squared of x plus cos squared of x will give you 1. So in this case, we have 1 minus sine of x out of 1 minus sine of x all squared, which is the same as saying 1 minus sine of x out of 1 minus sine of x multiplying 1 minus sine of x. So you see the numerator will cancel one of the denominators. So this will cancel this. So at the end, we just have our dy dx to be equal to 1 in the numerator. Remember, if you cancel out, this is not going to be 0 but 1. So we have 1 out of 1 minus sine x. And this is going to be your answer. I hope this is also clear enough. Now, let's look at some properties that you have to consider. So you have to know that sine squared of x plus cos squared of x is equal to 1. Also, secant squared of x minus tangent squared of x is also equal to 1. We also have cosecant squared of x minus cotangent squared of x is also equal to 1. Also, you have to know the multiple rule. So let's say you have cos squared x minus sine squared of x. This is cosine of 2x. We might use this later. And also, if you have 2 sine x cosine of x, is equivalently to saying you have sine of 2x. So you have to pay attention to these properties that I have listed right here. It will come in handy sometime. Okay, now let's move on. Let's solve another question. We have to find y double prime if y is equal to secant of x. Now let me pause this and go ahead to try and solve this question on your own. Pause the video. You can take as long as you want. Now I presume you've solved this. Okay, so now if you have y is equal to secant of x, remember from the properties that we wrote earlier on, if we differentiate secant of x, you get secant of x tangent of x. So now if you want to differentiate this, if you want to differentiate secant of x tangent of x, remember these are two functions multiplying, so you have to use the product rule. So for the product rule, remember your f is your first function, which is secant of x. Your g is a second function, which is tangent of x. So f prime, now if we differentiate secant of x, we have sec x tan x. And if we differentiate tangent of x, we have secant squared of x. So doing our substitution, we have y double prime to be f, which is just secant of x, multiplying g prime, which is secant squared of x, then plus g, which is tan of x, times f prime, which is sec of x, multiplying tangent of x. So in this case, we have y double prime is equal to secant cubed of x, then plus this times this, we have tangent squared. So we have tangent squared of x multiplying secant of x. And that is your solution. Okay. Let's look at this question. We have to find dy dx in, so our first question has got to do with when you have y equal to x cubed sine of x cosine of x. Now these questions are very tricky, When you have this, do you use the product rule? Do you use the quotient rule? What do you use? Now, whenever you have this, since we are multiplying, the best way is to use the product rule, right? So we have this to be f of g prime plus g of f prime. But now instead of two functions multiplying, we have three functions. So which one do we choose as f and which one do we choose as g? Now, in choosing your f and g, someone might choose f to be x cubed and g to be sine x cosine of x. You can also choose your f to be x cubed sine x and then your g to be cosine of x. In this case, let's choose our f to be x cubed and our g to be sine x cosine of x. If you differentiate x cubed, you have 3x squared, remember from power rule. Now, to differentiate sine x cosine of x, this is also a property that we have to note. Now, remember, as we wrote over here, you see we have 2 sine x cosine of x. 2 sine x cosine of x is equal to sine 2x. So if we make sine x cosine of x the subject, we are going to have, so this implies that, or let me say this is equal to, we can have sine of 2x out of 2. So having this, to find g prime, we can use the quotient rule. So g prime since we've used f and g over here to not confuse ourselves, we can have vu prime minus uv prime out of v squared. Out of v squared. In this case, our u is our numerator, which is just sine of 2x, and our v is our denominator, which is 2. If we differentiate sine of 2x, what do we get? Remember, whenever you differentiate something like this, you always differentiate this first. If you differentiate 2x, you have 2. And if you differentiate sine, you have positive cosine, so you just have 2x here. And if you differentiate a constant, you get 0. So doing our substitution, our g prime is, now v is 2, our u prime is 2 cosine of 2x, minus our u, which is sine of 2x, v prime is 0, and v squared is 2 squared. So this simplifies to 4 cosine of 2x. Sine 2x times 0 will just give 0. So 2 squared is also 4. So this is just cosine of 2x. Now we can go ahead to do our substitution. So we have y prime over here. So we have f, which is s cubed. So f was s cubed times g prime. G prime is what we just found, which is just cosine of 2x plus g. So g is what we know. So g is sine s cosine of x. Then our f prime is 3s squared. So we can rewrite this as s cubed cosine of 2x plus 3s squared sine x cos x. And this is our answer. I hope this is clear enough. Now let's look at another question. Let's say we have b. We have y equal to sine of x plus cosine of x multiplying secant of x. Now in this question, we can, which one do we think we should use? Do we use product rule? This to be our f, this to be our g? Which one do you prefer? One thing that you have to notice is this is secant of x, and we know that secant of x is 1 over cosine of x. So we can rewrite y to be this. Sine of x plus cos of x multiplying 1 over cos of x. So if we distribute it, we have sine x over cos of x plus cos of x over cos of x. So sine over cos is tangent, cos over cos is 1. So now we can go ahead to just differentiate this. So the y dx is d dx of tan x plus d dx of 1. dy dx is equal to, now what is d dx of tan x? If we differentiate tan x, we have secant squared of x. And now if you differentiate a constant, you always end up getting 0. So secant squared of x plus 0 is secant squared. So this brings us to the end of the video. So, and that's how the beauty of trig and calculus come together. Keep practicing, and soon these derivatives will feel as natural as second nature. Don't forget to like and subscribe, and join me for the next lesson, because math is more than numbers. It is the language of the universe. I'll see you. Bye.